Hello, Ben Pearson, the Roadster Tracker, and about a month ago I had the chance to see a total solar eclipse, which is a very spectacular event where the moon blocks the sun from us. And I started to think about it on my way home, which was a little bit extended. What would it actually take to make one of these artificially? Is that even something that's possible? And is it something we could even seriously consider doing? So I started thinking about this and I concluded that, yeah, it's at least theoretically possible. And let's talk about what it would require. So the first thing is you have to have an object that will block the disk of the sun, which is about 9 milliradians wide. Milliradian is roughly a degree, half a degree, something like that. Doesn't really matter, but those are the units that we're dealing with. And you don't want it to block the corona of the sun. So I'm going to say that you want to try to keep something between 9 and 11 milliradians wide. You can kind of see some of this as you drive around. The eclipse, there were parts of it where you could see the prominence of the sun because the moon was blocking off that part, but not the other parts. But you couldn't see the prominence, at least at the very beginning where I was. It was more towards the end that you were able to see it. And that was a particular diameter. So, you really want it to be pretty close. So, what would it take? Can you just stick a quarter up there and put it in front of the sun? Well, no, that's not going to do it. One of the important things to having the effect of a total solar eclipse is to have everywhere around you also be in the shadow of the object that's blocking it. So effectively, you want to have a dark sky. You can have some light on the sky. When the eclipse was happening, you could look around and it's effectively like sunset if you look all around you. Pretty cool effect. But you have to have something reasonably large to do that, to block out the entire atmosphere, and thus it has to be further away in order to do that. So if you're blocking out the atmosphere, let's talk about some possibilities. Well, you have to be above most of the atmosphere. So the first thing that I started to consider was some kind of a high altitude balloon. And effectively, the idea is you have a whole bunch of balloons that are carrying maybe between them some very, very thick, opaque material that will completely block out the sun below it. And you have them go up to an altitude that's high enough where they're going to be able to cast a shadow that will do this. Now, there's a couple of issues with this. First of all, you need to have it be directly below the target. So, if you're going for a completely horizontal surface, the sun would have to be straight above you, which means that it's going to be somewhere in the tropics region that this would affect. Only a small region, but it is still, at least possible at that. How big would it need to be? Well, let's say that it's going to be 20 miles, so about 30 kilometers high. That's about the highest that you could really have some kind of a weather balloon fly for any length of time. And in order to do it from that distance away, you would need to have a circle that was about 300 meters in diameter, about 1,000 feet roughly. But you could increase the size of this to about 370 to be at that 11 milliradian maximum that I was talking about earlier. And if you did that, effectively the difference between those two is the size of the shadow. So the shadow would be a 70-meter sphere. So, almost like an amusement park, you'd come up and you'd see this kind of shadow and you'd get in closer and closer and you'd have more and more shadow, but you have to be right in the center of it to be able to see it. So it'd be a pretty cool effect if you could get this all to work. Of course, you have to deal with, the winds that are going to blow it away there. And even if you could somehow make it stay stationary, you're going to have it's really unknown if this would work. You'll block out the sky to some extent, but this is going to be like a hybrid eclipse, the biggest hybrid eclipse that there was. But you're not really going to have the whole effect where the sky is completely black because the shadow is pretty small. You're only going to have a darkness for, the distance times 2 of the object. So if you have 370 meters or 1,000 feet, 2,000 feet, that's it. Only a couple hundred meters wide, less than a kilometer. It's not going to be very big, and you're not going to see the sunrise around. You'll see somewhat darkening of the sky, but I don't think you'd actually really be able to see the corona, which kind of defeats the whole point. Be cool, but we need to keep thinking about this. And also the material would have to be thick enough to block out all of the sun. And, that's going to be a lot of weight to carry in some kind of a balloon. So let's keep thinking. Let's think higher. So the next level is some kind of a satellite. And we're going to talk about 2 particular orbits. We're going to talk about something in low Earth orbit and then a higher orbit, probably geostationary orbit. So in low Earth orbit, you would have to have something, if you're effectively 10 times further, so you'd have to have this 3-kilometer circle. But there's a lot of issues. You have the direct overhead light problem, and effectively with a balloon, you could actually have it, operate at high noon, which would be pretty cool. But you're not going to be able to keep it there all the time. With a balloon, you could have it operate theoretically at high noon in a specific spot. But with a satellite, it's going to be basically impossible to line things up that accurately. So you would need to have something where it would work no matter where it was. So a circle alone wouldn't work. You'd have to have more of a sphere. And if you're talking a sphere that's 20 miles wide, that's going to cause some serious issues. You're going to have debris strikes on that thing all the time, and you're going to destroy other satellites that are up there. And not even only that, it won't work. The eclipse will pass over in just an instant over an area, even if it did somehow produce an eclipse. And most of the time, it's just going to be an annular eclipse. This thing would be a big nuisance, and it wouldn't really work. Okay, so let's move even higher. As you go higher, you get to the geostationary orbit. Now, for the same reasons why it's a bad idea in low Earth orbit to have this thing operating around, you probably don't want to do that in geostationary orbit because there's a lot of satellites that are there. But geostationary satellites remain somewhat constant compared to each other, so there's a little bit more maneuverability in that range. So let's talk though about something just a little bit beyond there. And this way it'll kind of move around to different spots. And let's not say pure geostationary, but let's just say that it's high up there and you're gonna let it move around. And so depending on exactly the time, it will always have an eclipse every time that it passes in front of the sun, but its location will vary from time to time. A geostationary eclipsing object would need to be roughly 400 kilometers in diameter. That's about 250 miles. And you want it to be a spherical type of shape for the same reason. And it actually probably wouldn't be too bad. It would move in an orbit about 2 miles a second, 3 kilometers a second. So you would have roughly 2 minutes of eclipse time as it's moving across the surface at the peak location, which would be pretty cool. It would have a daily effect, although if you are not exactly in geostationary orbit, then it would vary quite a bit. And overall, it would be a rather neat effect. I think it would work quite lovely. It's not always going to work. There's going to be some times of the year. This will work more towards the spring and the fall and less at the winter and summer. And the latitude and longitude will change somewhat. But this is actually something that is possible. And, if I did my math right, it'll block about 0.1% of the light of the sun received on the Earth, some measurable fraction. Maybe that's a little bit high, but that's only when it's actually blocking the Earth. It's only going to be doing that for a small portion of its orbit. But overall, hey, it's some small amount, could help with global warming a little bit, who knows? And it could have some other things. Now, it wouldn't be quite like the natural thing. You're not going to have things like Bailey's beads unless you purposely build this so it would have them. It wouldn't be quite as cool, but I think this would be a really neat idea. You could cover it with some kind of solar cells, have it beam the power back down to Earth so it actually has a practical application. And yeah, it's not the worst idea in the world. It'd be really cool, but man, I think this thing would be enormously expensive by today's dollars. Starship, though, could do something like this. We've talked about it before, how Starship could actually make it so that you could launch satellites into orbit to beam power down to Earth at a reasonable cost. And this could just be a part of that. They could kind of make this the goal to absorb all of the sun that goes through this area so that it creates a little mini eclipse. I think it'd be really neat. Not likely to happen, but it would be really cool if they could pull it off. Anyways, thanks guys for everything. I appreciate all you do. Until next time, keep on tracking. Take care. We will see you then. Bye bye.